Select your station and open the program to the Blocks folder. Double-click on OB1, the main programming block. Using the icon, open your program elements. Then using the toolbar and items from the catalog, we will begin a simple programming session. I0.0, I0.1, Q0.0 from the elements in the toolbar. Entering a new network using the new network icon. We now go to the Program Elements browser and select a move instruction with the example addresses MW20, MW22. We save our work with the disk icon in the toolbar. To select or change the programming language, first we open up the respective code block by double-clicking from the SIMATIC Manager. Now using the menu, View, Ladder, Statement List, Function Block Diagram, we can change the image of the actual code on our screen. To use symbol names, we first select our program folder and open the symbol table by double-clicking the symbols icon. Then we fill in our 4-column spreadsheet. Examples include the symbol name, the absolute address, the data type, and a comment. Save your symbol table using the Save icon. These symbol names are now available within your program. Continuing, we open the Blocks folder, opening a code block with a double click. We now turn on all the symbol choices under View, Display With, Symbol Representation, Symbol Information, and Symbol Selection. You can turn on all or one or two of these. You see the symbol information and the symbol name on the screen at the same time. To use the symbols as you write code, simply put in your program elements as you choose. In this case, a greater than with an input in front to an output. Then you either type in the associated symbol name or pick from the pop-up list of symbol selection. The data type is also checked as you try to use the associated symbol names. If the data type is invalid, you will immediately be notified with an error condition. Symbolic programming is more than just nicknames. Save your work with the Save icon. Open your station to your program folder, then select the Blocks folder. Using the menu items Insert S7 Block, we select Function, a subroutine. We select the names as we choose, symbol names, symbol comments, and programming language for our example ladder, then we OK. Double-click opens that block into the program editor. We now do some basic programming and some basic documentation. Using the program elements, this example uses a greater than integer box to an output. Using the addresses PIW 288 compared to the value of 1200, turning on Q4.2 output. Save your work using the Save icon. Your subroutine now becomes part of your instruction browser. Select your station, open the program folder to the Blocks folder. Using the menu Insert S7 Block, for this example we choose Function. We name and give our function its specific information, and then we select OK. Double-clicking our block opens the block into the program editor. To expand and view the local variable area, we slide the window. We then begin to enter our local variables, in this case variable 1 as an integer, and as you see as we continue we enter several variables as integers. We also choose a result as an output and include temporary variables. These variables are to be used within our code section. As we enter our code section, this example we will add 3 variables together using 2 add integer boxes. We manipulate our window to make everything visible on the screen. We now use our variable names as we selected earlier. These variable names have no direct connection to an absolute address. By using only local variable names, we are making a subroutine that is completely reusable. When we complete our code, we select the disk icon to save this subroutine. This subroutine will then become simply another element within our program catalog. Open your project and your program to the Blocks folder. Highlighting the Blocks folder and using the download icon downloads the entire program. If you answer yes to load the system data, you also download the hardware configuration for your station. You can selectively make downloads of individual code blocks, again by opening your program folder to the Blocks folder, then selecting only the block or blocks you choose to download. Select the download icon. In this case, since this block had been downloaded before, we had an opportunity to overwrite. To display program status, we must first go online. Using the online icon in the toolbar, we now open our project and our program through our station folder to access the information that's actually in the PLC. When we double click on a code block to access the program editor, we now open the online block. Turning on the monitor or eyeglasses in the toolbar, we now see data updated from the PLC. Notice at the bottom of the screen that your run indication is on. Digital logic, analog logic, and other data are represented. This example shows several ways to use different data types. First, double-clicking in the symbol table allows us to create data type associations with process symbols, their absolute address, and their size and structure within our program. Saving your symbol table allows access to these variables by name or address later. Continuing, we open the blocks folder, and for this example, insert a new subroutine called a function. We OK to construct the function, then double-click to open the subroutine. In this example, we also have another area where we can identify names and data types. These are local names, local variables that would be used in this subroutine only. Individual subroutines also support the same data types that are available in the global symbol table. Saving your work, we leave this subroutine. We open the main program block, OB1 in this example. We continue to build new networks, and we will now see examples of usages of different data types. The compare greater than integer boxes first. The data that is placed into the respective elements is data type checked to make sure it is the right size and shape for that instruction. Data typing builds integrity to your program. Saving our work, we continue. In this case, we see the data types that are brought into the respective areas.